All right, so we've talked about allowable stress design. The other type of design is generally categorized as limit state design. This is where we look at load and materials basically separately when we address those uncertainties separately, basically. So what does that mean? Well, we're going to have two types of factors. Instead of having just a factor of safety, we're going to have a load factor, which in this particular case, we're going to use gamma to represent the load factors. Gamma is usually going to be greater than 1 in a lot of cases. It might be 1.2 for dead load and 1.6 for live loads. And they're scaled based on which we think are most uncertain. Live loads are like moving furniture around or people. Those are a lot less, there's a lot less uncertainty, or a lot more uncertainty with that versus dead loads. We know what 1 inch of concrete weighs pretty accurately. On the other hand, we've got the resistance factors. This is based on the strengths of the materials, where we say the predicted strength is that load factor or resistance factor times, the resistance factor times the nominal strength of the material that we get from testing. And this is what we call limit state design. And this is going to be called load resistance LRFD design in the US. So the typical design criteria that we look at is we make sure that our predicted strength is greater than our predicted load. Our nominal strength is greater than our factored load, right? We calculate our nominal strength by using the predicted strength is our nominal strength times our resistance factor, and then we add the sum of all our load factors times the loads. And for the load factors, those are based on the type of load. So let's look at some different types of loads that we typically see. Dead load, that's going to be the weight of self-weight of the structure or what it's supporting, right? So if we're talking about a beam, we're talking about the weight of the beam plus the weight of the concrete floor above it. Those are pretty well documented, so we often use 1.2 for that. If we're using it in combination with live load, we'll use 1.4. If we're looking at live load by itself, we'll be using 1.6. Snow load is very similar to live load. We'll use 1.6 often for those calculations. Wind is usually around 1.6 in a lot of cases. Earthquake is kind of interesting because we already calculate earthquake loads using probabilities. We don't actually scale these at all when we're doing our design, our LRFD design. We want to make sure that we're not kind of double counting our probability. Now, where do you get these sorts of things? They're found in design guides and codes. These are based off of kind of international codes that are adopted locally, and these can vary kind of widely from state to state and depending on where you're designing this structure.